This is the story of the vampire planet, a terrifying cosmic world that does not nurture its moon, but hunts it, tears it apart, and devours it slowly, piece by piece, until nothing remains but dust and memory. It is a story of gravity's cruel power, the invisible lines that govern life and death in space, and the discovery that has rewritten everything we know about how planets and moons interact across the universe. Long before we found this vampire planet, humanity's search for exoplanets, planets orbiting stars far beyond our sun, began as a quiet dream. In the 1990s, the first confirmed exoplanets shocked astronomers, revealing a universe far more diverse and chaotic than our own solar system. We found gas giants, bigger than Jupiter, orbiting so close to their stars that their atmospheres boiled away into space. We found rocky worlds, locked in tidal heating, covered in endless oceans of lava. We found planets orbiting twin stars, painting skies with two sunsets instead of one. But none of these discoveries prepared us for a planet that actively consumes its own moon. The first hints of this cosmic predator emerged in the late 2010s, when NASA's Kepler Space Telescope picked up unusual flickering light patterns around a distant star system, roughly 65 light-years from Earth. Astronomers noticed that a rocky, Earth-sized exoplanet, later labeled an ultra-short period planet for its breakneck 5.7-hour orbit, was surrounded by a faint, dusty disk that should not have been there. Most planetary rings form from ancient debris left over from a planet's birth, but this disk was different. It was hot, made of rocky minerals like silicate and metal, and it was slowly shrinking, as if something was eating away at it, piece by piece. For years, scientists argued over what could create such a strange, fading disk. Some thought it was leftover material from a planetary collision. Others guessed it was a comet, torn apart by the star's gravity. But a team of more than 50 researchers across 3 continents noticed a critical detail. The disk was not orbiting the star, but the planet itself. That small shift in logic unlocked the entire mystery. This was not a ring from a long-ago crash, it was the grave of a moon. The planet was not a passive victim of cosmic chaos. It was an active hunter, using its own gravity to pull its moon closer, break it into fragments, and feed on the remains. Astronomers gave this world a nickname that fit its terrifying nature, the vampire planet. To understand how a planet can become a cosmic vampire, we must first learn about the most dangerous invisible line in space, the Roche limit. Named for French mathematician Devours Roche, who first calculated it in 1848. The Roche limit is the minimum distance a smaller celestial body can orbit a larger one before the larger body's tidal forces tear the smaller one to pieces. Put simply, it is the point where the planet's pull on the near side of the moon is so much stronger than its pull on the far side that the moon can no longer hold itself together. Gravity, the force that builds worlds, becomes the force that destroys them. Let us break this down in simple terms, no complex math required. Imagine holding a rubber ball in your hands. If you squeeze gently, the ball stays round. But if you pull harder and harder from both ends, the ball stretches, warps, and finally tears apart. That is exactly what happens to a moon that drifts too close to its planet. The vampire planet's gravity creates an invisible, unstoppable tug of war. The side of the moon facing the planet feels a far stronger gravitational pull than the side facing away. This difference, called tidal force, stretches the moon like taffy. At first, the moon only deforms, bulging toward the planet and away from it. But once it crosses the Roche limit, its own gravity is no longer strong enough to fight back. The moon does not crash into the planet in a single, fiery explosion. It is much worse. It disintegrates slowly, silently, breaking into smaller and smaller chunks. First boulders the size of mountains, then rocks the size of cars, then pebbles, then fine dust. These fragments form a narrow, glowing ring around the vampire planet, a temporary tomb for a moon that once existed. But the ring does not last forever. Every fragment inside the Roche limit is doomed. Collisions between rocks grind them down further. Drag from tiny amounts of gas in the planet's system slows their orbit, and the planet's gravity pulls them downward, one by one, into the planet's atmosphere. There, they burn up in searing hot meteors, their material merging with the planet's crust and core. The vampire planet grows slightly bigger, slightly more massive, while its moon fades into nothingness. NASA's James Webb Space Telescope gave us our first clear look at this horrific process in action. Using its powerful infrared vision, Webb detected the unique chemical signature of rocky moon material raining down onto the vampire planet's surface. The telescope found high concentrations of iron, silicate, and other heavy metals that could only come from a differentiated rocky moon, one with a core mantle and crust, just like our own moon. The data confirmed what astronomers had only suspected: this planet was not just breaking a moon. It was consuming it, feeding on the satellite that should have been its lifelong companion. What makes this story even more haunting is the contrast with our own solar system. Here at home, our moon is not being devoured. It is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. Tidal forces between Earth and the moon transfer energy, pushing the moon into a higher, safer orbit. The vampire planet suffers the opposite fate. Its extreme proximity to its host star and its super-dense rocky composition create tidal forces that pull its moon inward, not outward. For this moon, there is no escape, no peaceful orbit, no billions of years of quiet companionship. Its destiny was written the moment it formed, to be hunted, torn apart, and eaten by the planet it once called home. This discovery forces us to rethink the entire life cycle of planetary systems. For a long time, we thought moons were either stable forever or destroyed in rare violent collisions. The vampire planet shows us that slow, deliberate consumption is a common fate in the cosmos. Many ultra-short period planets, dozens of which have been found by Kepler and TESS, likely have hidden histories of moon eating. Some may have devoured multiple moons over billions of years, growing larger and more massive each time. Others may be in the middle of the process right now, their rings fading as they feed. These vampire planets challenge our sense of cosmic order. We like to imagine the universe as a place of balance and beauty, but it is also a place of ruthless survival. Gravity does not care about harmony. It only follows rules when a moon crosses the invisible line of the Roche limit. Destruction is not just likely, it is inevitable. The vampire planet also teaches us about the fragility of moons themselves. Exomoons, moons, orbiting exoplanets, are some of the most elusive objects in space. We have found hundreds of exoplanets, but only a handful of exomoon candidates, and none have been fully confirmed. The vampire planet's story explains why many exomoons never get the chance to survive. They are torn apart and devoured long before our telescopes can spot them. They are ghost moons, existing for a short time before being erased by their host planet's hunger. As we continue to explore the universe, the vampire planet stands as a powerful symbol of both terror and wonder. It terrifies us because it shows a side of nature we rarely consider: a planet that preys on its own satellite. It fills us with wonder because it reveals the hidden complex physics that shape every world in every star system. Every time we look at a planet, we now have to ask, did it eat its moon? Is it eating one right now? How many worlds in the sky are cosmic vampires, hidden in plain sight? This question drives astronomers to build better telescopes, design more sensitive instruments, and keep searching the dark corners of the Milky Way. NASA's next generation of exoplanet missions will focus on finding more ultra-short period planets and mapping their dusty rings, looking for the telltale signs of moon consumption. The James Webb Space Telescope will keep staring at these vampire worlds, unlocking more secrets about how they form, how they feed, and how they change over time. We often talk about exploring space to find life, to find habitable worlds, to find places that remind us of home. But the vampire planet reminds us that exploration is also about confronting the unknown, about seeing the universe as it really is, not just as we want it to be. It is a universe of incredible beauty and unforgiving brutality, of gentle orbits and ravenous hunger, of worlds that nurture and worlds that devour. This small, distant planet, 65 light-years away, has changed our place in the cosmos. It has shown us that our solar system's quiet harmony is not the rule. It is the exception. Earth and the moon are lucky. We exist in a system where gravity balances gently, where the moon stays safe, where life can thrive. The vampire planet lives in a different reality, one where survival means feeding on the closest companion. As we end this journey into the dark heart of the vampire planet, let us carry two things with us: a deep respect for the power of gravity, the invisible force that builds and destroys worlds, and a new appreciation for the peaceful bond between Earth and our moon. The next time you look up at the moon, take a moment to feel grateful. Not every planet is so kind to its moon. Out there, in the endless dark, cosmic vampires wait, and their hunger never ends. Please like, comment, share, and subscribe to the channel.